Hello everybody, this is a video answer key for the day 3 type 3 that is homework for tonight. So the intention of this video is that you have already done the type 3 all the way through, and right now we're just checking answers together. So what you can do is jump. So for example, jump to the end of a question. If your answer matches mine, you don't have to watch that part, you just move on to checking the next answer. If you check an answer and we differ, that's when you would rewind and then see where we're the same or what happened on that question. So for number 1, it says, when examining the equation of an exponential function, how can you determine if it is a growth or a decay function? Explain. Various answers count for this. I would hope that at first you wrote the general model. So f of x equals a times b to the x minus h plus k. In your answer, you need to be talking to me about b. B determines if it's growth or decay. If b is greater than 1, and it's a positive a, remember that's a little side note we're going to keep track of, it's growth. Meaning from left to right, it's increasing, moving away from the asymptote. If b is between 0 and 1, and we have a positive a value, which all of ours will, it's decay. Meaning that left to right, it's decreasing, it's moving towards the asymptote. So left to right, increasing. Here, left to right, decreasing. So it's very possible that I have some notes here you don't have. As long as your answer had the gist or the big idea that b is greater than 1, it's growth, b is between 0 and 1, it's decay, that is a good answer. Let's make it a great answer by adding in the sketches, talking about left to right increasing or away from asymptote, decreasing, in other words, towards asymptote. All about the b value. Numbers 2 and 3, we are revisiting our tables. Each of the tables below represents a function. For each table, determine if the data shows an exponential function, linear function, or neither. If it's linear or exponential, state the initial value and the rate of change or growth factor. Details matter here, okay? So really make sure you take your time on a quiz or a test. We don't want to lose points for silly mistakes. Let's take a look at this first one, number 2. I first pay attention to my x values. These are increasing by 1. My y values. To get from 7 to 4, my first thought is that nothing times 7 is 4 that I can think of. So first, let's see. To get from 7 to 4, that's minus 3. 7 minus 3 is 4. Let's check. 4 minus 3 is 1. 1 minus 3 is negative 2. Negative 2 minus 3 is negative 5. Negative 5 minus 3 is negative 8. So it's a constant rate of change subtracting 3. We're moving by subtraction, which means it's linear. Initial value. Remember, initial value when x equals 0, what's y? That's what we're looking for. Let's see, right here. When x is 0, y is 7. This is linear, So that means that I have a rate of change, and the rate of change is -3. The only optional piece of what I just wrote is this question: when x is 0, what's y? Everything else that I just wrote, I would hope that you have written. Did you show me your arrows? Did you circle your initial value? Did you actually write the word linear? Is your initial value correct? Did you circle rate of change? And did you write the rate of change correctly? Number 3, -4, 1, 4, 11, 14, 41. I'm not thinking multiplication of any kind because it just doesn't ring a bell when I look at this pattern. To get from -4 to -1, I would add 5, but then 1 to 4, that would just be adding 3. So right away, I know that this is neither. If it's neither, there's nothing else I can do, but please show me some kind of supporting work to show me why you're saying it's neither. Number 4, I check my x values. These are all increasing by 1. 4 to 12, these are getting big really fast. So I'm thinking multiplication of some kind. To get from 4 to 12, that's multiplying by 3. 12 times 3 is 36. 36 times 3 is 108. 108 times 3 is 324, and I keep checking, it works out. And you can use your calculator to check that out as well. Because we're moving by multiplication, this is exponential. Initial value, I'm looking for when x is 0 in the table. So my initial value is 108. Since this is exponential, I have a growth factor, and that growth factor is 3. Number 5, my x values are increasing by 1. To get from -11 to -5, that's +6. -5 to 1 is +6. 1 to 7, adding 6. This is linear because it's moving by addition. Initial value, look for when x is 0. That tells me my initial value for this one is 1. It's linear, so I have a rate of change, and the rate of change is a +6. Number 6, as soon as I see whole numbers that end up as fractions, I am thinking division. 8 divided by 4 is 2. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. And that division works. Half of 1 is half, or 1 divided by 2 is a half. Half divided by 2 is a quarter. And this has a kind of a cool connection to money, because if you think like 50 cents, half of 50 cents is a quarter. This is moving by division, which makes it exponential. Initial value, when x is 0, the y value is 1. We have a growth factor, but remember, growth factor is a multiplicative factor. It has to be in terms of what you multiply by. Dividing by 2 is the same as multiplying by 1/2. So my growth factor is +1/2. Starting with 7, we are talking characteristics of the function. As soon as I see that, right away, we need to write at the top, f of x equals a times b to the x minus h plus k. That is going to be our guide for the entire time. So given the function, identify h and k. and describe the shifts. Also determine the equation of the asymptote. So here's my guide. A times B, but this is not asking me for A and B. This is X minus H, and there's K. So here I know that H is a positive 4. Remember, the negative is built in, so a positive 4 was plugged in right there, and K is 8. This would be a shift right 4. H is always horizontal shift. K equals 8 would be a shift up 8. K is always the vertical shift. K also gets me my asymptote. Y equals 8. Again, I'm not asked for A and B, but just to talk about it, A is 3, B is 1/7. Here I'm asked for H and K. Up top, if it helps, I'll put X minus H to help myself out. Here's K. I see a positive 5, which means a negative 5 was plugged in to create that positive symbol, the positive sign. K is negative 6. This is a shift left. Oops, that's weird. Shift left 5. Shift down 6. H is always horizontal shift, left or right. This is negative, so it's left. This was positive, so it was right. And then K is always vertical, up or down. Because that's negative, it's down. K also gets me my asymptote. Y equals negative 6. And we're done. Number 9, we're going to take it a bit farther. It says, determine if the function is growth or decay, growth-like or decay-like, identify the asymptote, and sketch a graph. Make sure the asymptote is easy to identify on your graph. Make it clear. So I'm going to try to keep this in my sight. A times B. So A is 1/2. B is 3. Because B is 3, I know that this is growth. B equals 3. That is greater than 1. Asymptote comes from K. I wasn't asked for K, but to get the asymptote, I will look for K. K is 4, so the equation of the asymptote is Y equals 4. Before we talk about domain and range, let's actually sketch our graph. So Y equals 4. 1, 2, 3, 4. There's my asymptote. Make it really clear. Or maybe I shouldn't do dots. Maybe I should make it more like dashes. If you know your asymptote is right, use a highlighter. But highlighter is permanent, so make sure you're correct before you put something permanent. It's growth, so I know from left to right I am growing. I am moving away from the asymptote. I'm increasing. Left to right, increasing. Domain and range is the same domain and range we've been talking about all year. So for domain, we're talking left and right, range up and down. So when I come in from the left, I hit an arrow. I come in from the right, I hit an arrow. That tells me my domain is negative infinity to infinity. Instead of up and down, you could say bottom, come in from the bottom, and then come in from the top. However it helps you. Bottom and top, up, or down, up. I think I wrote that backwards before. Sorry about that. Come in from the bottom, then come in from the top. Or down and then up. You choose. Okay, so I come in from the bottom. This is definitely not going to be negative infinity, right? We have this asymptote that's affecting the graph. This graph is going to come infinitely close to 4, but never touch 4. So parenthesis 4. When I come in from the top, I hit an arrow. So that's infinity. So let's make a note. Value of K or asymptote, whichever way you like seeing it, affects the range. The domain will always be all real numbers. No restriction left and right. But when I look bottom and top, there's clearly a restriction here, determined by K or the asymptote, whichever way you like to see it. That's an important note. I'm even going to highlight it. Number 10. Put my model at the top. F of x equals a times b to the x minus h plus k. Here, a is an invisible 1. B is 1/2. A times b. A can't be 0. If this was 0, 0 times anything, this entire piece would be gone and you wouldn't even have an exponential function. So what we really have going on right there is an invisible 1 that's out front. It's just not written down. So A is 1, B is 1/2. Another way to think of it, what's in parentheses is always B, raised to the exponent. Type of function. Well, 1/2 is equal to 0.5. So I know that this is decay because B is 0.5. That is a value between 0 and 1, which tells me it's decay. To know my asymptote, I have to pay attention to K. I wasn't asked for H and K, but I know, because I know my model, that K here is -1. So my asymptote is y equals -1. I'll graph my asymptote first. So I go to -1 and I draw my dashed line. Using a highlighter will make it stand out, but just make sure you're right, because once you draw in a highlighter, it's permanent. That's y equals -1. There's my asymptote. Because this is decay, I know left to right, I am approaching. Oh, that's too close. I'm approaching the asymptote, but will never touch it. Or you can see it as decreasing left to right. My domain, I know, will be -infinity to infinity. My range, I come in from the bottom. This graph will come infinitely close to -1, but never touch. When I come in from the top, I get infinity. Looking at number 11, A is 4, B is 0.25. When in doubt, you can always, right above it, write the general form, A times B to the x minus h plus k. So A is 4, B is 0.25. I know that this is a decay function because B equals 0.25, and that is between 0 and 1. My asymptote comes from the value of K. Here, K is -5, so I know the equation of my asymptote is y equals -5. I'm going to sketch first and then decide my domain and range. So I'm going to draw a dotted line, 1, 2, 3, 4, 5, a dotted line at -5. So y equals -5, and that's my asymptote. It's decay, so I know that from left to right it is approaching the asymptote, or from left to right it's decreasing. getting exponentially smaller. For domain and range, back to basics. For domain, I come in from the left, and then I come in from the right. I hit arrows on both ends, so negative infinity to infinity, or you could write all real numbers. My range has a restriction. This graph will get infinitely close to -5 as a y value, but never, ever, ever, ever cross it. So parenthesis, -5, comma, infinity, because when I come in from the top, I do hit an arrow. Range by K. The range will always be restricted by K or the asymptote. Number 12. A is 7, B is 4. If I asked you for H and I asked you for K, what would you write? H is -1 and K is 3. I see a +1. I remember that it's x minus H. A negative is built in, so that means that a -1 was plugged in to make that positive. Type of function. This is growth because B equals 4. And when B is greater than 1, it's growth. My asymptote comes from K. K is 3. So the equation of the asymptote is y equals 3. To graph, I go 1, 2, 3. Draw a dotted, dashed horizontal line. It's invisible, that's why it's dashed. I'm going to label it y equals 3. That's my asymptote. And it's growth. So from left to right, the graph starts low and then increases, moves away from the asymptote. Notice I'm very careful to not show that it touches. It never will touch this asymptote line. Domain is all real numbers. My range is 3, comma, infinity. Because this asymptote is 3, the graph will come infinitely close, but never cross 3. So 3, comma, infinity, arrows on both ends. Here, A is 1 and B is 3/2. Because when I write my model at the top, f of x equals A times B to the x minus H plus K. A is an invisible one that's out front. That is A times B. This is my B value. So 1 is the invisible A out front. B is 3/2. With fractions, we always want to take it to a decimal form because that helps us to know where that value is relative to 1. Is it between 0 and 1 or is it greater than 1? Half of 3 is 1.5. In other words, half of $3, 3 divided by 2 is $1.50. So even though it's a fraction, this is going to be growth. B equals 1.5. That is greater than 1. So it's growth. My asymptote comes from K. K is -4. So the equation will be y equals -4 for the asymptote. I graph a dashed line, 1, 2, 3, 4. Label that. It's my asymptote. And since it's growth, it is going away. It's growing from left to right. Remember that this is a -4. That's where we are on the y-axis. The reason I put that note is because it'll help me. I know my domain is all real numbers. My range will be -4 to infinity. Again, for domain, I come in from the left first, I hit an arrow. Come in from the right, I hit an arrow. So there's no restrictions on the domain. There's definitely a restriction on the range because this graph will never ever cross this invisible dotted line, which means the graph will come infinitely close to a y value of -4, but never actually get there. So when I come in from the bottom, -4, coming from the top arrow, which means infinity. Again, a parenthesis, not a bracket right there, because you will never equal -4. (14). A is 3, B is 2.5. It's growth. If I asked you for H and K, H is -1, K is 7. That's a shift left 1 and a shift down, not down, shift up 7. So even though I don't ask you for H and K, keep it in mind that I could at any time ask you for any of those variables. Just because it doesn't ask you for H and K doesn't mean you're not responsible to know about it. So H is -1 because that's a positive, which means the negative was plugged in. H is all about horizontal shift, left or right. K is a +7. K is vertical shift. Therefore, I know that this is a shift up 7. The reason I know it's growth is because B equals 2.5 and B is greater than 1. Because B is 2.5 and 2.5 is greater than 1, it's definitely growth. Asymptote comes from K. Y equals 7 is my asymptote because K is 7. I'll graph that first. 1, 2, 3, 4, 5, 6, 7. Dashed line right there. This is growth. So from left to right, it starts close to the asymptote and increases, goes away from the asymptote. It's growing left to right. Domain is all real numbers. Remember that this is y equals 7, so this y value is a 7 right here. So my range will be parentheses 7, comma, positive infinity. We'll come infinitely close to 7, but never touch, which is why that's a parenthesis. Last one is 15. I'm going to put a reminder here about what the parent function is. A times B to the x minus h plus k. What's raised to a power is B. So mentally, I want you to think that's B. Right away, I know B is 1/4. A is an invisible 1 that's out front. It's just not written. As a decimal, 1/4 is 0.25. That tells me that this is going to be decay. My reasoning is that B equals 0.25. That value for B is between 0 and 1. My asymptote comes from K. And just to practice, let's say, what's H and what's K? Take a second, decide what's H and what's K. Here, H is 0 and K is 0. Because mentally, I want you to see that this is like x minus 0, and then a big plus 0 right there. Which means no horizontal shift, and no vertical shift. So the equation for the asymptote comes from K. K is 0. So y equals 0 is the equation of the asymptote. My domain will be all real numbers. I just know that. But technically, let's do the graph first. And you can just know that too. For all of these exponential functions, until we get into the real world, just on a graph, coming from the left, coming from the right, you're always going to hit an arrow. But let's graph first. So I put in my invisible dotted line on my y-axis at y equals 0. That's my asymptote. And this is decay. So left to right, it is approaching the asymptote. It's decreasing left to right, but will never cross. So my range is 0 to infinity, and we are all set. So tomorrow in class, we will have a quick skills quiz on all of this content. Be ready, and it'll be a good day. Brand new notes tomorrow. Have a good night, everybody.